Okay, so we're going to do number one here on this problem here. A farmer wishes to enclose a rectangular field using existing fence for one of the four sides. So if you look over here, we have an existing fence right here. Okay, so we don't need to include that into the fence we're going to add. That's already there. So the fence we're going to add is only three sides. We're going to have an X here, and this is rectangular, so there's going to be an X right here, and then there's a Y. So we got two X's and a Y. Okay, it says question one, write an expression in terms of X and Y that shows the total length of the new fence. Okay, well, the total length of the new fence is going to be 1A over here. What is 1A? The length of the new fence is the length of those three sides. I have two sides that are X and one side that is Y, so this is going to be 2X plus Y. And that's the expression in terms of X and Y. That's about all there is to that question. Not much going on there, okay? The farmer has enough materials for 2,500 meters of new fence. Show that Y equals 2,500 minus 2X. Okay, so in this question, this is 1B. We're going to say that our 2X together plus the Y is how much fence we're going to need. Okay, those two sides and then the length. The two sides right there are X and X, and then in the middle is Y. So we're going to add those together, and it's going to give me 2,500 meters worth of fence. So I'm just going to solve this equation for Y. I'm just going to say, okay, Y will equal 2,500 minus 2X, and that's all I have to show. I mean, that's really the question. Unbelievable, but there it is. Okay, so there is that. All right, then, so let's do part C. It says AX represents the area of the field in terms of X. Show that the area is equal to 2,500x minus 2x squared. The area of a field, or a rectangle in this case, is equal to the length times the width. In this case, though, I have x times y, because my width is x and my length is y, we'll call that. But I have an expression here for y. I'm going to plug this expression I already have into the y. So that's all this is going to happen here. That's all that we're doing. This is going to be x times 2,500 minus 2x. So when I distribute that, x in there, like this, it's going to give me 2,500x minus 2x squared. And that would be a sub x. And that's your answer. And that's what they want me to prove right here, and it's done. So this is really, I mean, not really complicated. This is 1C part 1 right there, okay? 1C part 2. They're going to ask me to find the derivative of this. So we just have this expression here. They're going to ask me to optimize the area. So we have to find the derivative of the area. So we're just going to take the derivative of this function we just found. Okay, so the derivative of the function above this one will be 2,500 minus 4x. And that will be your answer for that question. Okay, so we're done with part 2. Hence or otherwise, find the value of x that produces the maximum area. When they say hence or otherwise, you're going to use the answer you just found. And how do we find the maximum area? We're optimizing the area, remember? So for this, we are actually going to set this derivative that we found equal to 0. So my derivative, which is 2,500 minus 4x, will equal 0 now. That means that 4x would equal 2,500. We'll divide both sides by 4. And x, let's try 2,500 divided by 4. And that looks like that's going to be, okay. So that's a value of x that produces the maximum area of the field. And you're saying, well, how do you know it's a maximum? Well, if I were to take if we say step 3, which I show you the 3-step process of doing optimization, this is not a requirement, but if you were to take the second derivative, which is the derivative of the derivative we just found, this is just going to equal negative 4. Since the second derivative is always negative, there's no value of x that'll make it positive, we know that this has to be a maximum because this entire graph for the original function is concave down. It just tells you since the second derivative is always negative, the entire graph is concave down, so this has to be a value that gives you the maximum anyway. There's just no other way to it. So just showing you that second derivative test right there. So we know this is going to give me the maximum. They're asking now for part 4, find the maximum area of the field. So we'll go ahead and do that. So we have an area formula, which they gave me here in part C, which was 2,500 x minus 2x squared. Now what I'm going to do to find the maximum area is I'm going to plug in that value that would give it to me, which is 625. And for x, okay, so let's do that. 2 times 625 squared. And then we use the calculator. 2 minus 2 times 625 all squared. And that will give me this, which is, and this will be in meters, so this will be square meters. So it's quite a large enclosure there, okay? But there you go. That is my maximum area. Okay, so that's the question. Okay, so we're on to number 2. Let's get a different color pen here. Let's do, I don't know, let's do green, I guess. Is that working? Okay. Number 2. Okay, so this is number 2. A cylinder is cut from a solid wooden sphere of radius 8 centimeters as shown in this diagram. The height of the cylinder is 2h centimeters. Find AE, the radius of the cylinder, in terms of h. This is part A. Okay, so we're going to do 2A. If I look over here, AE is right here at the bottom, right here. So that's the radius of the circle on the bottom. But what I also notice is this is a right triangle, okay? So make an expression for A is pretty easy. AE squared plus h squared, because h is half of the total height, is equal to 8 squared, all right? So that means that AE is equal to the square root of 64 minus h squared when I solve for AE, okay? So that is very simple. That's the expression for it. That's your answer. Not a whole lot going on there in this question, okay? They want me to show now that the volume of a cylinder can be written in this form here, which is V equals 2 pi h times 64 minus h squared. Okay, so 2b, in this case, the volume of a cylinder, you should know, is the area of the bottom or the top, which is a circle. So the area of a circle is pi r squared. And then it's just times the height, the total height of the cylinder. Now, this is very important here, because what I have here is pi r squared, and I know that r is the same thing as AE. Oops, I don't know what's going on there. R is the same thing as AE. So I'm in a highlighter now. Good grief, having trouble there. Okay. AE squared then. And then this total height, keep in mind this is important, this total height is actually 2h, okay, not just h. So this is going to be, over here, this is going to be 2h. So here's what I got. I got an expression for AE, which I'm going to plug in through here. I'm going to plug in this, right? So what I have here is I have pi times 2h times 64, square root of 64 minus h squared, all squared, okay? So this is going to give me 2 pi h. When I take this, when I square the square root cancels with the square, so now this is going to be 64 minus h squared, and this is what they wanted me to find. That's your answer. They just want me to show that, and there it is. That's how you do questions like that when you show stuff, okay? They're just looking for that work. All right, so next question, 2C. Determine, correct the 3 significant figures, so they're going to want me to round here. The height of the cylinder with the greatest volume that can be produced in this way. Okay, so if I want the greatest volume, what I need to do is take the volume formula that I just found and take its derivative, okay? Whatever I'm trying to optimize, in this case the volume, since I want the greatest possible volume, I'm going to take the derivative of that, so I'm going to say V prime, okay? So I'm going to take the derivative of this with respect to h, but actually before I do that, let's actually rewrite this equation for V. I'm going to distribute this actual 2 pi h into here. So V is actually equal to 64 times 2, it's 128 pi h minus 2 pi h cubed, okay? And I'm going to take the derivative now of that, which is going to give me 120, is with respect to h. Derivative is going to be 128 pi minus 6 pi h squared, okay? Now, they want me to optimize that volume, so I'll set that volume equal to 0 and then solve it for h, and that will be the answer to this question. So I'm going to say that 128 pi minus 6 pi h squared will equal 0. That means that 6 pi h squared will equal 128 pi. So what I'll have here is I'll have h squared is equal to 128 pi over 6 pi. These pi's cancel. And what is 128 over 6? Let's say, so 128 divided by 6. So that's 64 over 3. So that means that h is equal to the square root of 64 over 3, which is really 8 over root 3. Okay, so we'll just put that in the calculator and round it to 3 significant figures like they want me to. So I'll say, what is 8? Actually, what is 8 divided by root 3 with a decimal? So it's going to be 4.618. So to 3 significant figures, that's 4.62. This will be 4.62. Okay, and that's in centimeters. And that will be your answer. Okay, so that's part C. Looks like I've already done 3 there. So let's do the last one. Okay, so that was 2C1. Let's do 2C2. Calculate the greatest volume, given your answer to the nearest centimeter. So the greatest volume, we already have a volume formula up here at the top. We're just going to plug in that 4.62 into it. So it's going to be really easy. Times pi times 4.62 minus 2 pi times 4.62 cubed. So, and that answer ends up being 1,238. So 1,238 to the nearest unit there. Okie doke. 3 here. A rectangular piece of card measures 24 centimeters by 9 centimeters. Equal squares of length x are cut from each corner. So that's what they're going to do. They're going to cut from the corners and fold up the flaps there to make a box, okay? What is left is then folded to make an open box. Yes, of course. All right, then. So the length L and the width W are as such, okay? All right, then. So W, okay. So write expressions in terms of x for L and W. Fine. All right, so 3A1. So 3A1. All right, so the length here. Now, if I go back over here, the length is this entire thing. So my length actually will be 24 minus 2x, because I'm taking away this part, and they're both of length x. So if I take them off, okay, and the whole thing is 24, it's going to be 24 minus 2x. Pretty straightforward. Okay, the width is going to be kind of the same thing. The width, same type of deal here, is going to be 9 minus 2x as well, because those are squares, so same thing happening. So we have 2 expressions here. Boom. Now, we're going to end up optimizing something here, and we're going to need one expression to do that and take a derivative of that expression. But so far, we have these 2 equations happening. So that's your answer for A1 and A2. Okay. So we've done this entire part here, and now we can go on. Show that the volume of the box will be given by that expression that they're giving you right here, this expression. Okay. Now, it stands to reason if you were to fold up the flaps there that are after you cut out the squares, they're all going to be x high. Okay, that's how long the flap is, or that's how tall the box is going to be when you fold them all up. So it's going to be here. We have 3b. Okay, they want me to show that volume. So the volume of the this is kind of like a rectangular prism. Okay, it's going to be length times width times height. okay? But I'm telling you that height's going to be x. So I have an expression for the length and width. We're going to plug them in here. So I got 24 minus 2x for my length, 9 minus 2x for my width, and my height, I know it's just going to be x. Okay, pretty standard stuff there. So now we're going to have to distribute all this mess. We're going to FOIL all it out and solve it. This is the question. So I'm going to distribute this 24 times 9 here. It's going to be 180 and 36. Okay, so it's going to be 216. And then we'll distribute that. So it's going to be minus 48x. And then we're going to have this part multiplied, so minus 18x. And then this times this will be plus 4x squared. All that's still getting multiplied by x. We haven't done that part yet. So I'll distribute the x through. Before I do that, though, let's combine these terms. Okay, so we'll combine these like terms here. So it's going to be 216 minus 66x plus 4x squared. All that's still multiplied by x. We'll distribute the x now. So it'll be 216x minus 66x squared plus 4x cubed. Let's reverse the order of those terms. So I'll get this minus this plus this. And that is actually what they want me to show in that answer. Okay. The next question, follow up. Find the derivative of dB dx. They're calling this my volume. They're calling the volume B. I don't really know why, but they're going to call this volume B instead of V. Fine. So instead of dV dx, we're just going to call it dB dx. It doesn't make a whole lot of difference to me. So this is part C. So it doesn't make really that much difference to me. Let's take this derivative. So this is going to be 12x squared. This is going to be minus, what is this, 132? Looks like. X. And then plus 216. And this will be my derivative. Not much to that one. And then, of course, when we take the derivative, we'll set it equal to 0 to find an optimization for maximum volume. That's what we're going to do here. So find the next question, find the value of x, which gives the maximum volume of the box. That's part D1. So D1 is we're going to take that derivative I just found, dB over dx, and we'll set it equal to 0. That means that 12x squared minus 132x plus 216 will equal 0. And we'll have to solve it. So we'll divide every one of these by 12. We'll factor out a 12 if we can. And what is that going to be? It's going to be, well, yeah, I can factor that out. It's going to be 11. And what is that going to be? 10. 240 would be 20. What's the difference there? 24. This should be 18, I believe. Okay, so we need factors of 18 to add to make negative 11. That's going to be negative 9 and negative 2. And then x would equal 9. And then x would equal 2. So here's the kicker here. I have two answers for this optimization, but that doesn't mean that there's two values that'll make this volume a maximum. And quite frankly, what's happening here is one of them is going to be, one of these values will give you a maximum, the other one's going to give you a minimum. Because when we set it equal to 0, you're finding the maximum and the minimum simultaneously, as it turns out. And one of these values will max out the volume, and the other value that you plug in for x will will minimize the volume. So you have to be very careful here. So which one is which, right? Calculate to find the maximum. What I'm going to use is a second derivative, actually. So I'm going to take the derivative of this derivative that I already found, and I'm going to look where the second derivative, which value, if I plug in 9 or 2, which one gives me a value that is positive. I'm sorry, which one that gives me a value that is negative, because I want this second derivative to be concave down, therefore giving me a maximum. So if I plug in a 9 or a 2 into the second derivative, I'm looking for the one that gives me a negative value because it tells me it's concave down. So we'll take the second derivative, which we'll call it d squared b over dx squared, which is your second derivative notation, which we don't frequently use anyway. This will be 24x minus 132, and that's it. Okay? And now what I'm going to do is I'm going to plug in both of these values, 9 and 2, into this value for x. One of them is going to give me a positive. The other one's going to give me a negative. It's pretty obvious which one's going to give me a negative, though. If I plug in the 2, that's going to give me a negative because I'm going to get a 48 minus 132. Now, whatever that is, it doesn't really matter. I just know it's what? That it's less than 0. That's the most important thing. So this 2 is going to maximize my volume. If I were to plug in the 9, it will actually minimize my volume because the second derivative will be positive, which means what? The graph would be concave up and there would be a minimum point. So this is the real key here, is that when your second derivative is negative, it's a maximum. When your second derivative is positive, it's a minimum. Okay? So the 2 will give me the maximum volume. So what I'm going to do is I'm going to plug in the 2 back into the volume equation. The volume equation, they already wrote over here for B. So this answer, D2, we're going to say my function B right here, which they gave me in part B here, is going to take on the value of 2. We're going to plug this 2 into all of these x's here, okay? So B sub 2, 4 times 2 cubed minus 66 times 2 plus 216 times 2. There's a lot going on there. I need a calculator. You'll need a calculator for this. I got one right here. Let's see. And then plus 216 times 2. And that gives me 200, sir. Okay. And remember, that was a volume, I think. See, where was I? Yeah. So that's a volume. So it's going to be in what units we have? Centimeters. So it's going to be cubic centimeters. Okay. This is what B is technically equal to. So that's what they're calling the volume again. Also, you should take notice, we said we used 2. Technically, we couldn't have used 9 if we wanted to up here, because if we were to plug in 9 into x, that wouldn't make any sense, all right? Because it wouldn't be possible. If I had this x right here, let's go over here. This x were 9 and this x were 9, this wouldn't be possible for this thing to be 9 as far as the width goes, so it's not possible anyway. So the only possibility was 2, but we went ahead and proved that mathematically, although we didn't have to, okay? But it's not a bad idea to do that anyway. But that was your answer for that one, so that's the volume of your box. That's part D right here, D2, and that's your final answer for this question. So let's go ahead and do number 4. The cost of producing a mathematics textbook is $15, and then it is sold for X dollars, okay? Find the expression for the profit made on the book. Okay, so the profit, let's do 4A. Let's do this in green, yeah. 4A. So your profit is equal to your revenue, how much you're making, minus your costs. That's called profit, okay? Your revenue is going to be X dollars per book, okay? So you have X dollars per book, and your cost is going to be $15 per book. That's what you're taking away from that. That's your profit for each book. Okay? So your profit, really, you could write this as X minus 15, honestly. All right? And that's in dollars, okay? That's your expression for this, not much to it. Okay. On the next question, it says a total of 100,000 minus 4,000 X books are sold. We're looking at this part right here. Right here, okay? Show that the profit made by these books is equal to that. Okie doke. So that's how many books are sold. So here's what we're going to do. My profit, that's the profit for a single book, is what I have here. okay, for a single book. So if I have a single book, it gives me this profit, and I have this number of books sold right here. I have to multiply the profit times the number of books. This is a profit for one book, so I have to multiply that number of books. And they say the number of books I'm selling is this. It's 100,000 minus 4,000x. They want me to show that the profit is equal to this thing right here. So we'll go ahead and do this foiling operation here. We're going to say x times 100,000 is 100,000x. X times negative 4,000 is negative 4,000x squared. Negative 15 times 100,000, we could call that negative 1,500,000. Most people would call that 1.5 million, but either way. And negative 15 times negative 4,000. I know that 4 times 15 is 60, so it's going to be plus 60,000x, okay? We'll combine the x terms right here. So we're going to get 160,000 x minus 4,000 x squared, and then minus 15 or 1.5 million, we'll call that. And as you can see, that's actually what they want us to have or prove right here. So we're done. So this was 4b. All right, moving on. Take the derivative. Find dp dx. We're going to take the derivative of this function right here, okay? So this is 4c. Take the derivative of this. So the derivative of p with respect to x, which we call dp dx, is going to be, the derivative of this is going to be 160,000 minus 8,000 x, and then derivative of this right here on the end will be 0. So this is going to be it. This is my derivative. Okay, and this is part 1. And then we're going to do 4c2, part 2. It says, hence calculate the value of x that gives you maximum profit. Now, to find the maximum profit, after we take this derivative, we took the derivative of the profit function. Now we'll set it equal to 0 to find a maximum. Okay, so we're going to take this equation we just found and set it equal to 0. That's all there is to it. So that means that 8,000x is going to equal 160,000. We'll divide both sides by 8,000. And we'll get x. Okay, these thousands are out, and this is going to be 20. Okay, so we have 20 there, and that's going to be my dimension here, x, which is the, well, x is how much I have to sell it for, as it turns out. We're selling it for x dollars a piece, so the value of x, or the selling price that will maximize my profit at this, will be 20. Okay, $20 here. My selling price. The next question here is calculate the number of books sold that will make this maximum profit if I were selling the selling price here. Okay, so I'm going to plug in this back into the number of books sold, all right? So the total number of books sold, they tell me in the question, this is 40, was 100,000. Oops. 100,000 minus 4,000 x. This is the number of books I'm selling. I'm going to plug this 20 back into here. So this is going to be 100,000 minus 4,000 times 20. So what I have here is 100,000 minus 80,000 really, minus 80,000. So this will be 20,000. So I got to sell 20,000 books at this with these formulas to maximize my profit. And that's your answer for this. Okay. All right, and I believe we're on the final question. This is number 5. There are 5 questions on this. And let's try to do orange here, I guess. Number 5. A closed box has a square base of side x and a height h. Write down the expression for the volume V of the box. Okay, so this is 5A we're going to do here. Okay, so has a square base of side x and height h. Okay, so if I imagine this box, try to draw this. It's got a square base, so every side is x. And it's got a height, which we're calling h. Not well drawn, but that's h, okay? So the volume here would be length times width, which are both x because it's a square base, times the height. So basically my volume is x squared h. That's the expression they want me to find for this answer. That's an expression for the volume of this box. So this is your answer for 5A. Not much to it, really. So we're going to do 5B now. Write an expression for the total surface area of the box. Okay, so the total surface area of the box, if you want to think of it this way, is if I had the base here and the top here, both of these would be x. The area of both these squares is really just x squared. So the total surface area, let's go and do this, the surface area, we're going to have 2 times x squared. That's going to give me those 2 sides. And now what I have now in this other bit here is I have to get all the sides here, not the top and the bottom, but all the faces. And all the faces are going to be x times h, and there's 4 of those around there, right? So if we're following this math here, we're going to say plus 4 times xh. So this is going to give me an expression for my surface area. Let's simplify that a little bit. This will be 2x squared plus 4xh. It's not really there. There it is. And that's my expression for surface area. So that's part B. Okay. The volume of the box is 100,000 cubic centimeters. So express h in terms of x. So these questions are really straightforward, really. I mean, it's not very difficult as of yet. So they're going to tell me that my volume here, I have a volume expression already from part A. And they're going to tell me this is 100, this is 1,000 actually, this is just 1,000, okay? It's going to be 1,000 here, and then we have this. So express h in terms of x, so basically h is going to equal 1,000 over x squared. And that will be that answer, okay? And that's for 5C. We'll do 5D. They want me to show that the area, or the surface area they call it, is 4,000 x to the power of -1 plus 2x squared. Okay, so here's the deal. I have my surface area, which they're just calling area, which is the same thing for me. And the expression I got for that was this. And what I'm going to do now is take this equation here and plug it in for h, because that's what h is equal to. So my area is now equal to this mess here. Okay, so if I multiply 4x by this, I'm going to have one of these x's cancel. Well, I'm just going to simplify it and just be methodical about it. So I'm going to multiply this by the top here. It's going to be me 4,000 x over x squared. So one of these x, the x right here on top is going to cancel with the one on the bottom. And what I have here is 2x squared plus 4,000 over x. You could write this, of course, as 4,000 times x to the power of -1 plus 2x squared. That's technically the same thing. And that's what they want you to show for this question, okay? So we've done all these parts, very straightforward. A lot of parts to this question. Now we're going to get to the optimization part. We're going to take a derivative. So We're going to want the derivative of the area function, okay? So this is the area function anyway. We already found it. And they want me to show that in that form so that I could easily take a derivative now. So this is going to be 5e. So they want to maximize the area, the surface area of this box. So we're going to basically take the derivative of a. So they want to say the derivative of a with respect to x. We have that function right above it right here. We're going to use that. So we're going to say this is going to be negative 4,000 x to the power of negative 2 plus 4x. Okay, that's it. That's that answer for that one. Okay, and then that's part E. Let's move on to F. So many parts here. Calculate the value of x that gives a minimum surface area. So we're going to set this equal to 0. I'm actually going to write this the other way in this form, which is easier for me. Maybe not easy for everybody, but easier for me. I'm going to write it like this. So we're going to add 4,000 over x squared to both sides and solve this for x. So that means that my x cubed is going to equal 4,000 over 4, which is 1,000. So x is going to equal the cube root of 1,000, okay? And I guess I could put that in the calculator. We'll go ahead and do that. Oops. Cube root of 1,000. That's going to be 10. Oh, nice. I should have known that, actually. Either way. So that's your value for x. That gives you the minimum surface area. Okie doke. And then find the surface area for this value of x. So the surface area, we had a formula for. This is the last question. Finally, we got to it. Was back up here. Was 2x squared plus 4xh. Okay? Or we even rewrote it right here. Is 2x squared plus 4,000 over x. So let's do that. I'm going to just plug in this x right there. So this area is going to be 2 times 10 squared plus 4,000 over 10. That's going to give me 200 plus 400, which is 600. And this will be in whatever units they're using. I don't know. Centimeters. So square centimeters, we'll call that. Okay, that's your surface area. And that's your answer for that one. Now, as you can tell, all the answers are at the end of this paper. Okay, I just left them on there. And you can see that the answer they got here is 600, and that's what I got here. So I'm just working out all the problems for you. And these are optimization problems. They're not very difficult. They're just taking, a little bit of patience, but no big deal. Okay? And I hope that made sense to you. It's not supposed to be difficult. And just practice it and look over this. Look over the answers. It's really not that difficult. And I appreciate you watching.